Hello, Math 120, and this is Professor Gonzalez, and I would like to do some problems from homework 4.3, which takes a look at division of polynomials. Now, when we start off with division of polynomials, if you're dividing by a monomial, right, a monomial, a single term, actually is not too tough to do because if you're dividing by a monomial, all you have to do is break a fraction down into two pieces in this case. Let me just kind of go backwards for a second. If you had in arithmetic, if you had something like, let's say 1/5 plus 2/5, and that equals, right, you'd call it 3/5, right? But 1 plus, whoops, you'd call it 1 plus 2 over 5, right? So we know that these two things are true from elementary school. What we're doing is we're doing this with polynomials where you have a binomial up top and we want to break it down into its two individual fractions. And so that's a legal thing to do. So our first step when we're dividing by a monomial, let's make sure this is only when we divide by a monomial. The technique is to break it apart. So it's going to be, you're going to have 4x to the fourth divided by 2x. And then what's the sign? Plus. And then we have 8x to the second over 2x. Of course, the denominator stays the same, right? And so our answer to this is the second B or whatever that one is right there. Let's take a look at another one. Now we actually want to go through the process. So it says divide the polynomial by the monomial. Check your answer by showing that the product of the divisor and the quotient is the dividend, okay? So what we're going to do is our first step is to rewrite this as, right, 3 individual fractions. So the first one we have here is, of course, the first term in that numerator is going to be 32 x to the fourth over 2x. And then our next one's going to be 34 x to the third. And that's over, I think I'm going to zoom in a little bit. And that's over 2x. And then we've got 22, excuse me, x squared. And that's over 2x. Now, another thing I would like to do actually before we continue is to put a little note right here. And I'll go ahead and let me try to wall this off here and say, this is called the quotient rule. This is the quotient rule for exponents, which basically says if you had something like, let's say you had x to the fifth over x to the third, well, what does that equal? Well, the rule says you can do this quickly. And once again, we're dividing, so if students get a little bit confused, why does the rule say that we can just subtract the exponents? And the correct answer is x squared. Well, the reason why we're allowed to do that is because if I took a look at this expression right here, and I rewrote that again, let me do this one in a different color. And let's say we had x to the fifth up top, which we know that actually equals x times x times x times 4, 5 of them being multiplied, right? And if we had, oops, that didn't work. And then if we had x to the third on the bottom, and we know that's just going to be x times x times x. Not sure why I used two different colors here. They're actually the same variable. And so we know the reason why you subtract the exponents is because when you're reducing common factors, that's just subtracting, right? 5 of those x's being multiplied, and they're being reduced and turning into ones. But essentially that 5 red ones minus 3 green ones is going to leave you with an exponent basically of x times x, which we know x times x is x squared. So really, all this stuff in green and red shows you why the rule's true. But, when you start having large exponents, x to the 50th power over x to the 25th power, you're not going to write all these x's out like that. You're just going to use your rule. You're just going to use the rule and and subtract, right? That's all you're going to do. Okay, so I wanted to kind of cover that as we're going to have to take care of that rule right here coming up. So now what we want to do is we want to simplify. And of course we've got, and I guess I'll use a red pen here. Let's do the coefficient first. You could say reduce 32 over 2, or because it does actually goes in perfectly, you can say 32 divided by 2. But I'm basically taking a look at this stuff right here. Whoops, let me get back here. I'm basically first taking a look at the numbers. So 32 divided by 2, well, that's just going to give me 16. And then remember, this is x to the fourth over x to the first. And so when you're taking a look at those exponents and you want to actually cancel them, right? You'd be canceling common factors. So 1x up top cancels 1x on the bottom, leaves with x to the third. Or you can just simply say 4 minus 1 leaves us x to the third, right? Using that quotient rule. Once again, going back, taking a look at our coefficients first. 34 divided by 2 is going to be, and we got the negative sign, negative 17. And once again, we've got this 3 minus 1 gives us x squared. And then going back, we have 22 divided by 2. That's going to give us 11. And then we have 2 minus 1 leaves us with just 1x. So there is the answer. That's all you have to put in to the computer. I believe they asked us to do a little more. It said, check the answer by showing that the product of the divisor and the quotient, is the dividend. Well, when you divide, by something, right, the divisor, if you multiply the product of the divisor times the quotient, which is the answer, you better get this. You better get the dividend. What's the dividend? The dividend is just this stuff right here. So they're saying they didn't actually require you to do this part, but if you wanted to do a check, they didn't require it in the computer. You would just multiply 2x, right, the divisor, times the quotient, which is the answer to this division problem, minus 17x squared plus 11x. And that's just a distributive property. So 2 times 16 is 32. X times x cubed is x to the fourth. And then 2 times 17 gives us 34. And then x times x squared gives us x to the third. And our last distribution right there is 2 times 11 is 22. And x times x is x squared. And that, if we did everything right, that should match that, right? Our quotient. 32x to the fourth minus 34x cubed plus 22x squared. And it does. Okay, so it's checked. Okay, next problem. Divide. Now we have a monomial, so we have to do the same thing. That negative in the denominator can really be kind of clumsy working through the whole problem. So I think I would do it this way. I would realize that on every single problem, you're dividing by a negative, which makes it opposite. I think I'm going to show it anyways. Let's just show it. So this is going to be 24 w to the third, and this is over our divisor of negative 4w squared. And then it says, let's do it this way. Let's say plus, and then let's put a negative 36w up top so we can make sure we really see the negative sign, divided by negative 4w squared, and then plus 28 divided by negative 4w squared, right? So that negative 4w squared, we've got to be really cognizant of that and make sure we take care of our signs. In fact, I think I'm going to do that right now. I know that a positive divided by negative is going to make a negative number. I know a negative divided by a negative number makes a positive number. And I know a positive number divided by a negative number is going to make a negative number. So those are our signs, just in case we lose what's going on. Once again, it should work out okay when we look at the signs, right? Look at that. A positive 24 divided by a negative 4 gives us a negative 6. Look at our, I'm going to go back to the color, I think, again. We have w cubed w cubed divided by w squared. So all we have to do is look at the exponents, and that would be 3 minus 2 gives me w to the first power. We have a negative divided by negative, which is a positive, just as we suspected. So 36 divided by 4 will make a 9, or a positive 9. And something that we have to be careful here is notice that if I take 1, if I used 1 minus 2, I get a negative exponent. Now, negative exponents is something that we will have very soon, but we haven't really talked about them much. So let's, instead of making a negative exponent, which is still valid, but we usually don't like to leave the answer that way. Let's just think of it this way. So let's first go ahead and tackle that a negative 36 divided by negative 4 is definitely our 9. And then we also want to make sure that we see we got a w to the first up top and a w to the second. Okay, so let's think about that. If we reduce by canceling, right, reduce a w, one w up top, and reduce or cancel out a w on the bottom, doesn't it leave a w on the bottom? And yes, it does. So let me rewrite this answer. I've got an answer of 9, and if it's a whole number, right, the 9 goes up top, and then I'm still left with a w in the denominator. Okay, so now on the last problem, we've got a positive 28 divided by negative 4, and that's going to produce a negative 7. Remember, negative 7 or negative 7 is equal to negative 7 over 1, right? They're the same. So that negative 7 actually stays up top because we still have a denominator, and the reason why we have that, let me go ahead and use some color to kind of make that pop out. So we've got 28 divided by negative 4 gives us the negative 7, okay, and that is definitely up top. If you want to say negative 7 over 1, that would be fine, but notice we have our w squared, and that is left in the denominator, so it needs to occupy that location. So we got, oops, and I put a double negative because I already put my negative there, so I got to be careful there. So there we go. There is the actual solution to that problem. Like I said, just be careful with the negative. I kind of over-talked that one, I think. Let's move on to the next one. And the next one is just more complication, right? Just got to be more careful as you do these problems. Let me take the space down below and write this out. Once again, we're going to tackle this problem in this fashion that I'm going to do because notice the denominator is still a monomial. How do you know if it's a binomial? Well, it's a binomial if it had, you could have that same 11x to the 12th, y to the 4th, but these are all being multiplied, so it's just one term. A binomial would have to have a plus or minus, and then another term, something like that, right? Or you could even have, well, that'd be like terms if I made them exactly the same. So anyhow, a binomial is going to have that separation of a plus or a minus. So we know for sure that this thing in the denominator is a monomial. And how do you tackle monomials? Well, you break them down like we did previously. So that'd be 28, and that's x to the 16th, y to the 8th. This is all divided by 11x to the 12th, y to the 4th. And then we have plus, and of course we have 88, and that is x to the 3rd, y to the 9th. And our same denominator, 11x to the 12th, y to the 4th. And finally, our last term is 11x to the 7th, y to the 4th. And this is divided by 11x to the 12th, y to the 4th. Okay, so now we have to do our reducing. And what did I reduce? I think I used red. And so let's look at our coefficients, and we look at, darn it. We look at our coefficients, and that 28 over 11, that doesn't reduce, does it? So that has to stay as just simply, and I'm going to write it right here. think I'm going to get rid of my monomial because it's kind of in my way, my monomial labeling. But anyhow, 28 over 11 does not reduce, so it's still 28 over 11. And then let's see what else happens. Well, we could focus in on this guy right here, right? X to the 16th, X to the 12th. Okay, reduce, 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 reduce. We're left with 4. And where are they at? Yeah, they're up top. So we're left with 4 x's up top. X to the 4th, not 4 x's. X times x times x times x. So it's x to the 4th. Now let's take a look at the last variable. I don't know if I really want to have this much color, but I'm going to do it anyways. Okay, we have common factors. So reduce away, right? Cancel common factors. You're going to cancel 4 common factors, and then there's 4 y's being multiplied left up top. So that'd be y to the 4th power up top. Okay, moving right along, we go to the next term. And the next term has some nice reducing that's going to happen with our, man, I did that again. Nice reducing that's going to happen with our coefficient. We've got 88 over 11. So 88 divided by 11 is just going to give us a whole number of what? 8. Now, I don't know if I'm going to have anything left on top or bottom. So I think right now I'm going to call this 8 over 1. If all the, after we reduce, we left with x's and y's up in the numerator, then we don't have to have it over 1. But I'm suspicious of something here. Let's see. Let's see what happens. Let's go to our next color, which is yellow, which is comparing, looking at x's. I got x to the 3rd over x to the 12th. Reduce 3 of them, and I'm left with how many? I'm left with what? Yep, I'm left with 9 on the bottom. So x to the 9th in the denominator. So I can just write this as x to the 9th, and that's x to the 9th in the denominator. Now let's take a look at our next. I think that's the color I used, yep. And so we have y to the 9th up top, y to the 4th, reduce, 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 4 of them, and we're left with y to the 5th up top. Okay, and then we're down to our last situation here. And we go ahead and we look at our coefficients. Whoops, that didn't work. We go to our coefficients, and that would be 11 divided by 11, which gives us 1. So that reduces nicely. Then we move on to our next x to the 7th over x to the 12th. Well, you reduce 7 of them, right? Cancel or reduce 7 of them. And that's going to leave, what, 5 left on the bottom. So it's going to be x to the 5th in the denominator. And then finally, we're left with the y values. And I'm seeing y to the 4th of y to the 4th. They reduce perfectly down to 1. And so we're left with, yeah, you have to put a 1 up top. You can't just leave it hanging there, right? So you have to have 1 over x to the 5th. So there is our outcome. That was a tricky one. A lot going on. So now you'll notice that we have a big change, a big difference. So far we've been dividing, and this is a nasty monomial on this one. But so far we've been dividing by a monomial, and what do you do with that? Well, you just break the fraction down into its individual terms divided by the denominator or the divisor, and then reduce each one of them. But now notice we are dividing by a binomial. Now, dividing by a binomial, we have a totally different way of doing it. We could not do it the same way as before, because it would leave a binomial in the denominator, and you're not allowed to reduce when you have a subtraction symbol. You could only reduce factors, and factors are only when you have multiplication. So because of that subtraction symbol, if you had a 4 up top, you would be highly illegal to do that kind of thing because of that subtraction symbol. So the strategy that we had before that was working great will no longer work because it's a binomial. And why is it a binomial? Because of that subtraction symbol. Okay, or even if it was addition, just as long as there's 2 or more terms, it's no longer a monomial. So now we've got this this procedure, and I went ahead and selected the step-by-step, and sometimes I don't know if this is anyways, I always wanted to give you guys a problem that steps you through it and kind of guides you, guided practice. It just, for me, sometimes it feels more cumbersome than because I'm just used to teaching it the way I want to teach it. But let's go ahead and do this as a guided practice, and I'll just show you how I do the problems. Very, very similar. Um, so let me just follow what they're saying. Okay, each polynomial is in standard form. Now the standard form that you want, right, is called descending power. So you've got 3, you're starting with the highest power, x to the third, x to the second, x to the first, and then x to the 0, or just a constant, really. So you want that to be in that descending order in that standard form, okay? It says divide the leading term. So they're trying to give you a way of figuring out what actually goes here to start our problem. Now I do it a little bit different. The way I do it is I say question mark, what times 2x will give me 10x cubed? And a lot of people, when they see that, what times 2x? What times 2 gives you 10? 5. Okay, so there's going to be a 5. And then what times x will give me x cubed? And most people come up with x squared pretty fast, and that's the right number to put there. I'm going to do it the way they do it, which is a very popular way also, and that's fine too. I really don't care which way you do it, but the way they do it is by this whole here it says divide the leading term. I'm looking right here, divided by 10x cubed. So by the leading term of the divisor 2x. So they're basically saying take this leading term of the polynomial, and that's going to be 10x cubed, and literally divide it by the leading term of the divisor 2x. And when you reduce that, 10 divided by 2 is 5. And of course we have our x to the third over x to the first leaves us with x squared, which is the same thing I got doing it the other way. So it doesn't really matter how you do it, but whichever way you do it, you got to do it correctly, okay? So there's different ways of doing that. So anyways, we got our 5x. That's the main thing here. 5x squared, rather. So now what's the next step? Well, the next step, you have to take your 5x and distribute it. Really what's happening is you're doing the distributive property right there. It's 5x squared, the number you came up with, times the divisor 2x minus 4. So you just use the distributive property to come up with the next line, right? 5x squared times 2x is 10x cubed. So that goes here. And then you do your next distribution. 5x squared times negative 4 is minus 20x squared. Okay, and so that's where that comes from. So usually we don't have to really write more work over here. You could just kind of mentally just do it this way, right? And do your distribution that way. If it helps writing on the right, then that helps, and do it, right? Okay, now next line. We got to be really careful. I'm going to switch colors here. I want to be very careful with this. I'm going to start with black here. Notice what we have right here. I'm going to highlight this, and then I'll get rid of the highlighting in a second. Okay, so the other thing I usually do when I show this stuff, and I didn't do it because I went right to their problems, I usually show like division from elementary school, because this is long division of polynomials, which does follow, division from elementary school. So let's say this was, I don't know, 156, let's say. Okay, so you'd say 5 goes into 1. Oh, no, it doesn't. 5 goes into 15 3 times. So notice we're multiplying, right? That's what we did on our long division, polynomial long division. That gives us 15. Now we subtract, and guess what we're going to do right now? Guess what our step is right now? We're going to subtract. Notice the subtraction symbol. And then you subtract, right? And then the check that you have to do here is this number remaining must be must be smaller than the divisor. Otherwise you could have gone in another time. And if that's satisfied, then you bring down the next number, and then you ask, okay, 5 goes into 6. Well, 1 times 5 is 5, and you subtract, and 1. You have a remainder of 1. Now you could write remainder of 1 as R1, but another way you can write a remainder is as a mixed number, and that's the way we would do it. With a polynomial, you'd actually say plus. With a number, you don't have to say plus. In fact, we don't say plus there. It still would actually be technically correct. But 31, and the remainder goes up top, and what goes in the bottom? The divisor goes on the bottom. So it's 31 and 1/5. So we're going to do the same kind of thing with polynomials. Now what I'm trying to get at here, let me get rid of this real quick. I'm trying to really get at this subtraction symbol. This is polynomial subtraction. And we know from before, remember when we had polynomial subtraction, if we had something like this, and we had like 2x squared minus 5x plus 1, what do we do before we subtracted with polynomials? I always recommend that you think of this and distribute it. And when you distribute a -1 or a negative, all it does is change the signs. Notice this sign was plus, now it's minus or negative. This sign was negative, now it's plus 5x. This number is positive, so now it's -1. So really, when you see this situation, let's do it again. When you see this situation right here of subtracting a polynomial, really all you have to do is just change their signs. And I'm just going to do that with these problems. I'm going to change them in green just so we know I changed it, right? So that becomes negative, that becomes positive, and that becomes negative. And I would just do that because then all you have to do is add them up. So my point is polynomial subtraction here. Be really careful. So what do I do with this? I distribute the -1. So it's just a plus out front now. So that becomes a negative, and that becomes positive. Now you have to do the next step, which is, now that we distribute our negative, now you just add them up. So what is a positive 10x cubed and a negative 10x cubed? 0. Now this little 0 right here has to happen at this step. This little 0 has to happen at this step. If you get something other than 0, it means you picked the wrong number up here, and you got to go back and start again. Okay, this must be 0 with the first term. Now the second term could be anything, right? So let's see. We've got negative 10x squared plus 20. That's going to leave us with a positive 10x squared. Okay. All right, so that is done. The next problem, now the way the book does this particular step, the way I've always taught it is I would bring down the next term and go from there. And that's many books I've seen do that, and it actually matches up with our arithmetic. You just bring down the next one. If there was another one, you bring it down and bring it down one term or one number at a time. This book tends to want to bring them both down, but it doesn't really make any difference if you bring them both down. We're just going to tackle 2 at a time because our divisor has a binomial. Okay, so our next step, and you can see they wrote down the results of this, I think. Oh yeah. Okay, so the results of this is just right here, right? So it's the same thing I wrote down up there. Our next step is to start the process again. So this is an algorithm, which is a series of steps that loops back around and starts again, kind of like a computer program. And here we go. Now we're looping around again, and we do the same steps again. And if I did it my way, I would say, what times 2x will give me 10x squared? That's how I like to do it. The book likes to do it this way. The book likes to do it this way, which is fine too. 10x squared, take the leading coefficient, divided by your leading coefficient of the divisor, 2x. And then you don't have to guess what to do. It's just 10 divided by 2 is 5. X squared divided by x is x. And so you know the next has to be, the next number up here has to be 5x. Okay. Now ultimately what you're trying to do is you're trying to match, let's see if I get some color on this. Whatever this is, that's what has to happen when you multiply this and this, right? The 5x times 2x has to be 10x squared, just like up here. Why do we pick 5x squared? Because 5x squared times 2x will give me my 10x cubed. That's what you have to do, because once you do that, then in the subtraction step, you'll get 0. All right, let's see what happens in the next step. The next step says, please multiply. Remember, we're multiplying the new number that we just put here, and it must be distributed to each term. So it's going to be 5x times 2x is 10x squared. Perfect. 5x times a negative 4 is negative 20x. Okay, and that's exactly what they got right there, right? Now they're saying subtract it is our next step, subtract it. And we know with subtraction of polynomials, or binomials in this case, it's probably better for us to just change the signs and add them, because it gives us the same answer and mentally it's a little easier to do. So our next answer is 10x squared and a negative 10x, 0. Remember, once again, that has to happen. Otherwise, go back to the drawing board, you picked the wrong number. And then I've got negative 10x and a positive 20x, which is 10x. And then they just drop that down, right? So there it is right there. So we should be at the same spot. I'm just a little sloppy. Try that again. This ended up, whoops, what's that other piece there? Okay, so this ended up being 10x, positive 10x. And that's the same, that should be the same thing they have here. Let's just take a little peek here. There's that, right? 10x minus 20, and there's your 10x minus 20. So that's where we're at right now. Now we're ready to do the loop or the algorithm once again, right? So it's the repeating part of this algorithm. And the question, the way I like to do it once again is what, question mark, times 2x will give me this 10x squared. You guys know what it is? If you said 5, you're correct. 5 times 2x is 10x. I don't know if I said square, it's just 10x. And once again, the way that the book likes to do it is they like to take this 10x, divide it by the divisor to figure out what number needs to go up top here. And 10x divided by 2x is just 5. And so just as we suspected before, that is going to be a 5. And now our next step, right? Next step, what we have to do is we have to distribute. So 5 times 2x gives us that 10x. Well, actually, that's what they're going to do down here. Okay, now let's show it. Okay, this step was just to write the 5 up there. And then the next step is to actually distribute like I'm about ready to do. So it's just, that's why sometimes I don't like these step-by-steps. I would kind of blend these a little more, but it gives you something to go back to. So the next step is to distribute your 5. 5 times 2x gives us a 10x. And 5 times a negative 4 gives us negative 20. Now remember, the next step is to subtract, so there it is right there. And when we're subtracting polynomials, I prefer to add and change their signs. Gee, that's really far away. Plus, change it to plus, so change the signs. So now we've got, of course, we've got a 10x and a negative 10x, so that's 0. And once again, like I told you, that has to happen. If you don't get 0 in that first term when you're subtracting, or you're subtracting the binomial or polynomial, you've done something wrong if you don't get a 0. So now we've got a negative 20 and a positive 20, that's 0. So it turns out we have no remainder. Man, that seemed like a lot, huh? I'm going to streamline this a little bit better, and then we'll also have something called synthetic division, which will go much quicker, actually. So we found out that when we divided by this binomial, what did we get? Well, we end up getting our final answer here was 5. What was it? Here it is right here. We could highlight it right here for us. Final answer. They didn't give me much space to squeeze it in here. The final answer is 5x squared plus 5x plus 5. And then they're asking what's the remainder? Well, the remainder was right there. And so the remainder is 0. All right, moving on. Oh, more? Okay, they want us to do more. So they say verify the quotient times the divisor plus the remainder equals the dividend. So just like any division problem, right? Even back here in arithmetic, if someone wanted to know, is this correct? You could actually take your divisor and multiply it by your quotient, the answer, and that better give you this dividend, right? And same thing here, except that they're polynomials, so they're a little bit messy, right? So we go through and we multiply, and it turns out when we do the multiplication here, which is not anything too fun to do, because look at this: distribute, distribute, then distribute, distribute, then distribute, distribute, and then collect all like terms. And when you do that, you will find that you get that. What do you get? You'll find that this, after you multiplied, will give you that original divisor. Where was that original divisor? Way up here, which was this guy right there, right? The original divisor, or that numerator right there, which was 10x cubed minus 10x squared minus 10x minus 20. And that should match perfectly. There it is. Okay, now I'm going to do this long division with smaller problems just so you get the feel of what's happening here. Once again, why are we doing polynomial long division? Because it's painful? No. Well, it is painful, but because we can't break it down like we did on those earlier problems because it's a binomial. So polynomial long division is one of the ways to do this. There are actually a couple different ways, but this is what we're learning today, right? So this is going to be a divisor of x plus 4, and that goes into this polynomial of x squared plus 5x plus 4. Okay, so how do we do this? Okay, here's how I like to do it. I like to say question mark. What times 4 gives me x squared? What times, I don't even know what I just said. Question mark. What times x gives me x squared? Let me say that again. Question mark. What times x gives me x squared? And yes, I heard everybody yell out, that has to be x, because x times x is x squared. And x times 4 is 4x. So now what do we do in our procedure? Well, now we just subtract, right? And how do you subtract a binomial or any polynomial? The best thing to do, I would say, is to distribute that negative sign, which just changes all the signs of the problem. So now we add. And x squared plus a negative x squared is 0. Perfect. That has to happen. And then we have 5x and a negative 4x just gives us an x. Now we go ahead and bring down our next term, which is 4, and we do the procedure again. Question mark. What? Get rid of some of these. The question mark is what times x gives me x? And I think I heard everybody yell out 1. And that is correct, because I can show you distribution. 1 times x is x, and 1 times 4 is 4. Now what's the next step? The next step is polynomial subtraction. How do we do polynomial subtraction? Easiest way is just to distribute that negative sign and change the signs. And now we add them up. So a positive x and a negative x is 0. A positive 4 and a negative 4 is 0, so we have no remainder. The answer to this is x plus 1. Okay, next problem. I'm running out of space. Okay, I think I can actually just get that to go through to the next line. So the next one is going to be 2x plus 5 divided by 2x squared plus 11x minus 19. Now, something to be aware of. You want all of these problems to be in standard form, and so you want those exponents to be descending power of x. That means your x squares, whoops, just erased. Your x square was first, then your x to the first was next, and then your constant. right? This is x to the first and then constant, so it's just always the highest power first and then descending down. Let's go ahead and use my tried and true technique. Question mark, what times 2x will give me 2x squared? What factor is missing? What times 2x will give me 2x squared? Well, you can see that x times 2x gives me 2x squared, and x times 5 is 5x. So now our next step is polynomial subtraction. So I'm just going to go right to the idea that if I want to subtract these, I just change their signs. Change their signs and add them up. So 2x squared, negative 2x squared, 0. Check, that has to happen. Next, I have 11x and a negative 5x, which gives me 6x. Now I've got to bring that negative 19 down. Next question. Question mark. What times 2x will give me 6x? Question mark. What times 2x will give me 6x? Well, what times 2x? Darn it. I believe what it's going to be is 3. Let's see. 3 times 2x is 6x, and 3 times 5 is 15. Now remember, our polynomial subtraction is next. And what's the best way to subtract polynomials? Just change your signs and add them up. That will be the same as subtraction. And we're very happy to see that a 6x and a negative 6x is 0. So check, that worked out. And I've got a negative 19 and a negative 15. So this is actually getting to be quite a bit of a bigger problem. This is number 7. So we have negative 19, negative 15, which is negative 34. And you know that this is a remainder, mainly because the power of the divisor is 1, and the power of this is a constant, so you can't divide anymore. So this is now considered a remainder. How do we write the remainder? So the way we write the remainder is, notice it's a negative 34, so minus 34 is the remainder over the divisor. What's the divisor? Divisor's right here. 2x plus 5. So what is the full answer? The full answer would be, and I put it in MyLab this way just to make sure it was going to take it. It's x plus 3 minus the remainder, which is going to be 34 over the divisor, 2x plus 5. And that is the answer. Okay. Now we've got more polynomial long division. Let's see if we can squeeze this in. I think what I want to do is I'm going to put 8 right here. And it says divide using a long division or polynomial long division. Something that I always want to make sure is happening is to come, look at this problem when I first have it and make sure it is in proper order. 3, 2, 1, and then constant. That's good. Okay, so that is ready to go. So now my divisor is going to be 2x minus 1. And then this, of course, is standard form, 6x cubed plus 7x squared, also known as descending order of x, so descending powers, 11x plus 3. Well, I should say that those are equivalent ideas. But anyways, you want this to be in standard form. You want them to be in descending power of x. So now, how am I going to do this? Remember how I like to start? Question mark. What times 2x will give me that 6x cubed? Question mark. What times 2x? So first of all, 3 times 2 is going to give me 6, right? And then x squared times x is going to give me x cubed. So I think we got it. 3x squared times 2x is 6x cubed. And now distribute to the next term. 3x squared times a negative 1 is just negative 3x squared. And then we go ahead and use our polynomial subtraction. And we know subtracting polynomials is probably easiest just changing the signs and adding them up. And then we find the results. 6x cubed, negative 6x cubed, 0. Perfect. That means we got the right number up here. But now we have 7x squared plus 3x squared. That's just going to be 10x squared. Bring the next term down, and that gives us minus 11x. Now, you go ahead and ask the question again. Here's our, notice the loop, you notice the repeat for the pattern, which is, the repeating part of the algorithm is question mark again. Question mark, what times 2x give me 10x? Well, why don't we start with just the number. What number times 2 gives me 10? And everybody yells out 5. Okay, good. 5 times 2 is 10. Now what times x will give me x squared? Oh, x. So now let's go ahead and distribute. 5x times 2x is 10x squared. And 5x times a negative 1 is minus 5x. Okay, all good? Polynomial subtraction means you change the sign. That's plus, so make it minus. That's minus, now make it plus. And then simply add them up. So a 10x squared, a negative 10x squared, 0. So perfect, we're on the right track. Negative 11 and positive 5 is minus or negative 6x. Let's take our last term and bring it on down. And finish the procedure once again. And what's the procedure? Big old question mark. What times 2x gives me negative 6x? What times 2x gives me negative 6x? Well, a negative 3, that's it, right? Because, get this stuff out of my way, because a negative 3 times 2x is negative 6x, and a negative 3 times a negative 1 is positive 4, right? Let's see, where am I at here? Is this number 8? 3x squared is 5x minus 3. Oh, what did I just do? I just forgot how to multiply, I guess. I don't know what I did. Anyways, I'm seeing 3. Let me redo this line right here. You probably all caught what I just said. I did it to keep you focused. No, I just made a mistake. Anyway, so this is negative 3 times a negative 1 times a negative 1 gives me positive 3. Jeez. Okay, one mistake makes this whole thing blow up. That's a tough thing about math sometimes. So now we have to subtract, and remember polynomial subtraction just means to change those signs and add them up. And when I change the sign, I get a 0. Good, that had to happen. And oh, bonus plan, I get another 0, which basically just means there's no remainder, is what that means. So now we're going to go ahead and write our answer down. Our answer is 3. I'm going to zoom in because of space. 3x squared plus 5x minus 3. 3x squared plus 5x minus 3, and that's the answer. Let's do one more. This one's even a little more wicked in some ways, but it's good to practice some of the tough ones. So I'm going to go back to black. We really want to make sure that we have our order is correct. So let's go through. A 4, looking at the power. 4, 3, 2, 1. Remember, when you don't see a power, it means it's to the first power. And then constant, which is a 0 power. Okay, so that's good. And then also our denominator is square first power constants. That is all looking really good. Let's go ahead and write out, which space do I have? Oh, I've got a lot of space. So I'm going to start right here. This is going to be called number 9, and number 9, and it will be right here. And the divisor is w squared minus 2w plus 2. That's just that guy right there. And it's going into our dividend, our numerator, which is 2w to the fourth minus 5w cubed minus 7w squared plus 26w to the first, if you will, minus 30. Okay, this looks hectic, but we go to our procedure, which just says question mark. What times w squared gives me 2w to the fourth? Well, remember that w squared has a 1 in front. So if we're just thinking about the number first of all, just to simplify things, well, I know if I say 2 times 1, I'm going to get a 2. So that's the number. And w squared, I need w to the fourth. I need w squared. So let's check ourselves here. Remember, I have to match this leading term, so when I subtract, it goes away. Okay, so 2w squared times w squared is 2w to the fourth. And then 2w squared times a negative 2w is negative 4w cubed. And finally, 2w squared times 2 gives us a plus 4w squared. Now remember, our polynomial subtraction is best done by just changing the signs and adding them up, right? Change the signs and add them up. Also, we know 2 and a negative 2, w to the fourth, is 0, and that has to happen, which confirms that we picked the right number up there. Next, we continue with our addition now because we changed the signs. Negative 5 and a 4 is negative w cubed. And negative 7 and negative 4 makes negative 11w squared. Good. So now what we want to do is, let me just make this a little bit. Okay, now what we want to do is bring down the next term. Okay, so now question again. Get rid of these guys. Question again. Question mark. What times w squared gives me a negative w cubed? Let's see, where are we at? So what's going to do that? So right here, what times w squared makes a negative? Well, we have to have a negative sign to make a positive into a negative, right? So negative times a positive is going to be negative. And we're also missing a w. So let's see if this works. Negative w times w squared is negative w cubed. Perfect, we matched it. And negative w times a negative 2w, negative times a negative is positive 2w squared. And negative w times 2 is negative 2w. Next step is to do our subtraction. The best way we like to do subtraction is changing the signs. Change the signs and simply add them up. And I explained why we do that, so I'm just kind of jumping into that now. Negative w cubed and positive w cubed, 0, so that confirms, yay, we definitely got the right number or term right there. We've got a negative 11 and negative 2, which makes negative 13w squared. And so then we have 26 plus 2 gives me 28w. And so now what do we do? We're at the time of the step, just like in arithmetic, that we drop down our next term. So we have minus 30. Okay, if you see the pattern, the loop, right, the repeating part of the algorithm, the repeating part of the algorithm is going to be question mark, what times w squared gives me negative 13w squared? Okay, so we're going to have a negative, so it's going to be negative 13 times w squared gives me negative 13w squared, right? I just did my distribution. Then I distribute the next thing. Negative 13 times negative 2 is positive, 26w. And negative 13 times 2 is negative, what are we at, 26. Now we're going to subtract. We do our polynomial subtraction. We change our signs. We add them up, and we get 0, which has to happen, perfect. And I've got a 28 and negative 26, so that's going to be 2w. And I've got a negative 30 and a positive 26, that's negative 4. Okay, now notice, you know when you're finished with this procedure, when you see the power of the divisor, back at this step they were equal, oh darn it. Back at this step, the power of the divisor was equal to the power of this dividend we're trying to go into. So you can go one more time. But now, the power of this dividend that we're trying to work with now, or the piece here, is first degree. And so we're done because second degree is a bigger number. So this is now considered the remainder, right? So how do you write the remainder? How do you write that remainder? Okay, well, let's do it. I've got to go over here space-wise. Here's the answer. Well, I'm going to write it down here because space. So the answer was in red. My stuff in red up here, right? So you can see what I'm looking at. I need to incorporate all that, and I actually need to incorporate that too. So here we go. It's going to be 2w squared minus w minus 13. It's going to be plus my remainder, which is 2w minus 4, right here, right? Divided by my divisor, which was w squared minus 2w plus 2. And there it is, right? There it is, 2w squared minus w minus 13. And then the remainder is 2w minus 4 all over the divisor. And that's the answer. Let's take a look at the next problem, number 10. Now, number 10 goes into a new method that it's called synthetic division. So what synthetic division does, I get this phone is going off like crazy, driving me a little crazy. But the synthetic division, let's make sure the house isn't burning down or something. Oh, of course. Anyways, that's gonna have to wait. So the synthetic division can be used when you have a binomial in the denominator, and more specifically, when you have a binomial that has the highest power of x is only 1, right? So a linear, you can say x to the first power. So this makes our procedure much faster. I've got a step-by-step kind of guided solution, and then I'll do it. I'll show you. This is really fast. What really happens with these problems is if you go back to this problem, you can see that there is a whole bunch of redundancy, things that happen over and over again, right? Because, I mean, notice how many times I wrote w squared here, right? I wrote w squared, w squared, w squared, w squared, w squared. You know, how many times I write w? And so I wrote w all through here. So there's a lot of those variables are causing us to write the same thing over and over again. And so if I can just ditch the variables for a little while and then put them back in at the end, that would save a lot of space. And then also the other part that's really, really annoying is subtracting binomials, because you got to change their signs or you have to distribute the negative. It's just annoying. So I'm not sure who came up with this, but some genius mathematician in the past came up with this synthetic division, which uses just much less space. It looks like it uses a lot because they're kind of stepping you through it. But anyhow, let's see. I got to respond to this. Gosh darn it, it's driving me nuts. People know I'm lecturing, but they just keep on wanting to. Okay, so now what we're going to do is each polynomial in standard form. So what we have to do, we have to make sure it's in this standard form, just like I said before, right? What does that mean? That means that we've got third power, second power. Ooh, we're missing a power, aren't we? So this guy, right, because we're going 3, 2, and then no power. So the very first thing you have to do with this is rewrite it. 4x cubed plus 17x squared. I don't have any x's, so that's just a 0. It's basically a placeholder, if you want to think of it like that, because 0x is just 0. But I need that place, because if I'm going to ditch my variables, when I do this synthetic division, notice the variables are not there, the x cubes and the x squares and so on. So if I'm going to temporarily ditch them, I need to have that place holder being there. Otherwise, it's going. Inevitably, you're going to be adding and subtracting unlike terms is really the big problem. But you don't really have to know all that. You just have to know that you have to have this in descending power or this standard form. Let's make sure we're good now. Let's see. I got a 3. Jeez, I hate it when it does that. I've got a 3, 2, 1 constant. So I know, and once again, right, when you have x to the first power, that's a first power. You don't have to put a 1 there. So now I have everything I need. So they would like us to start our division problem. Row 1, what do we need here? Well, we're going to need all the coefficients. What are the coefficients of my polynomial that I have here? The coefficients are just the numbers in front of the variables. That's what we need to focus in on. That's what we need to focus in on. So what are the numbers? Well, they already put down 4. Okay, 4. Then they already put down 17, 17. I need to put down 0. And I need to put down a negative 12. Okay, so now we know how to set that up. Now, the next thing that's very important is what's our divisor? Now, if this was normal polynomial long division, your divisor would just be that guy right there, right? Divisor would be that guy right there, which I'll write right here, x, whoops, that would just be x plus 4. But when you're doing synthetic division, what you use is use the c value. And the c value is just going to be whatever's the opposite of that constant that's attached to the x. X plus 4, you're going to use the c value of negative 4. If it's at x minus 4, you're going to use a c value of 4, positive 4. It's always the opposite. Okay, so then over here, our c value is just going to be negative 4. Now, notice before it was a positive x plus 4, and I think by introducing that opposite thing, which means negative, it takes care of the subtraction. It builds it in, right? It's kind of ingenious. It's built in now. So now you don't have to subtract, you just add. So let's see how this works. So what we do as our first step is that the first step is you bring a 4 down. Well, that's nice. Okay. Then the next step, you multiply. Next step, you multiply the 4 times the negative 4. If you multiply 4 times negative 4, you get negative 16. And then the next step, all you have to do is just add those two columns, those two numbers in the column. 17, 17, and a negative 16 is just 1. And then you just do the same thing over and over again. And see, look, this is very simple and it goes really fast. What do we do previously? Well, we said 1 times negative 4, right? 1 times negative 4, that gives us negative 4. So this right here is going to be our negative 4, and you'll see it show up. We're supposed to do it here, negative 4. Okay, what next? Now we just add them up. We just add up our column. Here we do it on the next step. Add it up and we get a negative 4. And so the algorithm is just very, very simplified. Now we just multiply. Ooh, I almost messed up. We multiply a negative 4 times negative 4, which then gives us negative 4 times negative 4 is going to be positive 16. Whoops, but they want me to put it here because I'm doing step by step, doing a play by play. Okay, so 16 goes there. Flip the page. Yeah, that's what they got. Same thing. Good. And then you just add them up. Negative 12 and 16 is going to give us 4. And now your big question is, what the heck does this mean? Well, when your last term is a number, that's your remainder. How do you interpret this problem? Therefore, the quotient, the answer is what? I mean, it just looks like these numbers. Here's how you interpret the problem. You go back to the original problem. Notice it was third degree, right? Let's call it third degree. We just divided it by a first degree, right? If you divide a third degree by a first degree, guess what? It drops the answer down to a second degree. So therefore, our answer must be a second degree. So you take your information right here, and you can write the answer. 4 has to be a 4x to the second degree. We're putting our variables back in. The next thing I see is 1, and that must be to the first degree. And the last thing is -4, which is our constant. And there actually happened to be a remainder of 4. So we just write that as 4 over the divisor. What was the divisor back in the original problem? The divisor was this green x plus 4. Divisor was just x plus 4. Oops, I guess they wanted a remainder down there. This is how you would write it actually if you're going to have a finished problem. They broke it apart on this particular one, so we'll go ahead and work with that. They said, therefore the quotient is this, therefore the remainder is 4. Okay. Okay, then they did have it all completely done down here. The original polynomial is this, it checks out. Therefore, okay, let me write it down here. Therefore, x, so it's 4x squared plus 4x squared plus x minus 4. It has a remainder, so we write the remainder as a fraction of 4 over the divisor of x plus 4. Here we go. Let's do some synthetic division. I think you're going to be very happy with how fast this goes. Here's how we do it. Let me kind of wall that off there. I'd like to start with my divisor, which was x minus 6. Now that's a binomial. What's the c value? C value is going to be opposite of negative, so it's going to be 6. So now this will go very fast. Don't blink your eyes because it's going to be done. Put down, now once again, right, make sure that our descending power is there. 2, 1, constant, we're good there. Okay, so I'm going to write down, instead of writing down an x squared, write down its coefficient. What is its coefficient? 1. What is the coefficient in front of the x? -8. And what is the last constant term? 12. Now remember, the first one always goes down. I'll go ahead and do this in red. The first term always gets dropped down, and it's a 1. Now we multiply 1 times 6, which gives us 6. Then we add, and we get -2. Then we multiply. -2 times 6 gives us -12. Then we add a positive 12, -12 gives us 0. So this has a remainder of 0. Now we interpret our problem. Well, the divisor was second degree. The denominator is first degree. So a second degree drops down to a first degree when you divide it. And so therefore this 1 is just going to be, put the variables back in, it's just going to be 1x minus 2, and that's it. There is no remainder. Let's do another one. I think I need to be a little more conservative with my space. Let's do this. The denominator is x plus 2. Therefore, our c value is -2. So let's set it up. -2. Let's look at our values. We have a 3. We have a coefficient of 4. And we have a coefficient of -4. Of course, I had to make sure that they were all descending power of x, that there weren't any gaps like that first one where we had to put a 0 in to hold the space. 2, 1, constant, so that's looking really good. Now we go through and we just go through our steps, and here's where it goes fast, right? You drop down the 3, and then 3 times -2 is -6. Add them up is -2. -2 times -2 is positive 4. And add that up and you get 0. Once again, that's always your remainder. So we know we have a remainder of 0. Let's interpret this problem by putting our x values back in. Well, our divisor, our dividend, also known as the numerator, in this case is a second degree, and our denominator or divisor is a first degree. So you just subtract 1 degree off. 2 minus 1 gives us a first degree. So this is just going to be 3x minus 2. There's our answer. 3x minus 2. Let's do the last one here. I'm definitely running out of space here. So let's see. Let me see if I could really squeeze it in here. Uh-oh, and this one has to have, this one needs a little more space because you could see on this one, we actually have something that needs to have a space because I go, so you can see I go from 3 to 1. That's not good. Let me make this pen a little bit smaller so I could fit more into this little space. So I'm going to rewrite this as y cubed. I need to have a space holder so I could have a y squared. And then I got minus 22y. And then I got plus 38. And once again, what that does right there for us is it keeps like terms lined up when we're adding things together. Because we're going to lose our variables and we're not going to know what's like. The other thing we need to know is this is our binomial. And it's so therefore its c value is going to be positive 4. So we got to remember that. So let's see if we can fit it all in here. So we got a 4. And our coefficients are going to be 1, 0, negative 22, and 38. Bring down the first one. I'll do this in red now just to show you my work. Bring down the first one. Now we got 1 times 4 is 4. Add them up. 4. 4 times 4 is 16. Add them up. Negative 6, right? Negative 6 times 4 is negative 24. And add that up, 38 and a negative 24 gives us 14. Hey, we actually have a remainder on this one. Okay, so interpret the answer. Interpret the answer. Well, this is a third degree, and this was a first degree, so 3 minus 1 gives me 2. This is going to be, I'm just going to write it down here. I'm just going to write it down here. This is going to be 3 minus 1 is 2. So this is just going to be y squared comes from the first one. And then I got plus 4y to the first. And then I got minus 6. Now my remainder is going to be plus 14 over the divisor, which was just y minus 4. So there is our answer. Y squared plus 4y minus 6 plus 14 over y minus 4. We're almost done. Getting there. So we have this problem right here to do, and this is showing our function notation. So let's start with a. I think I'm going to do a right here. And so we have our function notation. We've got f. What does that mean? What does that mean? F over g of x. Well, that literally means f of x, the function f of x, divided by the function g of x. Hey, it's division. It's what we're doing, right? So if I were to really kind of highlight what is the f of x function? Well, the f of x function is this guy right here, right? So can I just put that up there? So what is the f of x function? It is 10x cubed plus 6x. Hoping I have more space than that. Do I? Oh, I don't. Darn it. 10x cubed plus 6x squared minus 10x. And it gets divided by g of x. What's g of x? Well, g of x is just... What's g of x? G of x is just that right there, which is just 2x. Hey, it's not a binomial or trinomial. It is simply, a monomial. So how do we divide monomials? Go back, way back to the beginning of this these homework problems, and all you have to do is just break them down into individual fractions. That would be 10x to the third over 2x, and then plus 6x squared over 2x minus 10x over 2x. And then simplify each one of those. And so the first term I get is 10 divided by 2 is what, 5? So it's going to be 5, and x to the third reduced with one of them is going to be x squared. My next term I'm going to look at is right here. 6 divided by 2 is just 3. And I've got x squared up top, reduced with 1x, leaves me just 1x up top. And then finally I've got minus this last term, and 10x divided by 2x is just going to be 5. So that is finished. 5x squared plus 3x minus 5. And then finally, they're asking us to use the same exact division of function f divided by g, but they want to plug in a value of 3. So we can just use this new function we just developed, right? And realize they're saying take that input and square it, multiply by 5, then 3 times that input, x minus 5. And once again, what's our input? What is our input? It's 3. Let's replace all those x's with 3 and simplify it, and we've got ourselves an answer. 3 squared is 9, so this makes 3 times 3 is 9. 9 times 5 is 45. And then 3 times 3 is 9, minus 5. So we've got 45 plus 9 minus 5 is 49. Okay, need a little water. And some food, actually. But anyways, let's take a look at the last two problems here. So we got 15 and 16. I got to watch my space here. Okay, I'm going to do 15 in 3 different ways because I just want to tie some ideas together. So I'm going to really stretch 15 out. But I'm going to show you 3 ways because I think it's important to kind of put this all together. We've got something new here called, this is new, it's called use the remainder theorem to find the remainder. Remainder theorem to find the remainder. Can I just use polynomial long division to find the remainder? Answer is yes. Can I just use, because look at the divisor is just a linear, right, x to the first power, so couldn't I use synthetic division to find the remainder? The answer is yes. They want us to use the remainder theorem to find the remainder. Well, that's a very specific thing. The remainder theorem says that let me make sure I can say it. Now look at this divisor divided by this guy right here. What is its c value? Well, the c value would be -4. So therefore, the remainder theorem says that if you substitute the c value into the function, the answer to that function will be the remainder. That's kind of not obvious, I don't think, at all. But look, let me go ahead and do it. I'll show you a couple different ways. So I'm going to take my function, and what am I going to substitute into the function? I'm going to substitute in my c value, which is -4. And the remainder theorem says if you put the c value into the function, the result of that substitution will be the remainder if you divided, long division or synthetic. So what does the function say? Well, it says take x and square it, then take 10 and multiply it times x, and then add 29. So what is our input? We already said it. It is our c value, which is -4. So let's simplify this then. Well, -4 squared is 16. And 10 times -4 is -40 plus 29. So when we add that up, 16 minus 40 plus 29 is 5. So by the remainder theorem, we actually found the remainder without even doing any long division. Okay, I want to show that you could have gotten this by long division also. So let's do that. Okay, let's do the same problem. So this is number 15. This is how you're supposed to do it, by using substitution of that c value, because that's the remainder theorem. But I also want to just kind of prove to you, and also it's a good idea to do this, I think, just to give you, a review of some things, right? So if I did polynomial long division, the divisor would just be x plus 4, and that's supposed to go into my dividend, which was x squared plus 10x plus 29. So we go through our procedure, maybe a little faster because we're better at it. What times x is x squared? Oh, it's just x. X times x is x squared. X times 4 is 4x. Then we do our polynomial subtraction, which means you got it, change the signs. And now simply add them up. Gives us a 0, which gives me confidence I've got the right number up there. 10 and a negative 4 is going to be 6x, and we bring down our next term. And then we go through the procedure and ask, what times x will give me 6x? Well, plus 6 will do that. And then, so we just multiplied, and then 6 times 4 is 24. Polynomial subtraction means all you have to do is change the signs and simply add them up. So we get 0, perfect, and in this case we get a 29, and a negative 24 leaves us with a 5. We just found out that the remainder is 5, which is exactly what we got back here, which is what the remainder theorem is, right? You can actually find the remainder by substituting the c value into the function. Let's tie that together by doing, so this is called polynomial long division, and this is called synthetic division. So let's do that same problem, but with synthetic division. Now, synthetic division uses the c value, so negative 4. It uses the coefficient on each one of these terms. So it would be 1. Next one coefficient is 10. Last coefficient is 29. This will really illustrate the speed of synthetic division. You can see my long division on the right. So how do you do this? Bring down the 1. Then 1 times negative 4 is negative 4. Add them up is 6. Multiply 6 times negative 4 is negative 24. Add them up and you got your remainder of 5. Yikes, that was fast, right? This started out with a second degree problem and ended up with dividing by a power. So our result is going to be 1x to the second. Sorry, it started out with the second, so it's going to be a first degree answer. So 1x plus 6, and the remainder is 5. And that's the same thing we got when we did our long division, right? And of course the remainder would be written as 5 over x plus 4. Okay, so I did that problem 3 different ways, but the intended way and the big takeaway here was, that this is the remainder theorem. It helps us find the remainder without having to do any division, right? You're doing direct substitution. Last problem. Use the remainder theorem to find the remainder. Okay, this time I'm not going to do it 3 times. Let's just do it right here. It says the divisor is x plus 7, so therefore the c value would be negative 7. And we're going to basically just substitute it back into the function. And what does that function say? It says cube the input, 6 times the input squared, minus 17 times the input, minus 67. Whew, that's a lot. So now what is the input again? The input we said was negative 7. So simply put negative 7 in for the input of x. And then we say negative 7 cubed is negative, so this just becomes negative 343. And then, of course, negative 7 squared is 49. And 49 times 6, 49 times 6 is 294. And then negative 17 times negative 7 is 119. Minus 67. And when we sum all those pieces together, we end up getting f of negative 7 equals 3. What does that mean by the remainder theorem? It means the remainder whoops, the remainder is 3. If you were to divide this polynomial by this binomial, so the remainder is 3. And we have completed all of the problems from this section. Okay, I hope that helped out, and take care and have a great day. Bye.